All right, section 2.2. Today we're going to be starting off operations with radicals, okay? So first off, this is just kind of a little review of what we did last class, simplifying radicals. We talk about what a radical is. What is a radical? Yeah, it's just like that whole thing, right? It's that entire thing, okay? So the radical symbol, we see the arrow it's pointing to, it's the black part. Okay, the index here is what? On this first one? It's a 3, right? So that's just whatever our root is. If it's a square root, what's the index? 2, okay? We then have a coefficient out front of our radical, okay? Right there, it's a 5. And then the radicand is what is underneath of the radical symbol. Okay, so same as last class there. Again, if the index is not shown, it's implied to be a 2, just a square root. Those are the only roots that don't have a number written on their index. All right. Let's go ahead and just kind of review. These first two are like what we did last class. So we worked with that factor tree, right? We break down these numbers as far as they will go. So 50, what can I break that down to? 10 and 5. So the two numbers that multiply to get to 50 are 10 and 5. Can 5 be broken down further? No. What about 10? Yeah, what can it be? 2 and 5. Okay? My index on this one is what? 2, right? Because it's not written, so it's a square root. Groups of 2 that I'm letting into my party. Do I have any? Yep, the 2 5s, right? So this just becomes 5. What's left? 2. Does it have a friend to go to the party with? No, there are no other number 2s. So that means we leave it underneath. It stays home. Okay? Think about that root as being your home base. So that is just the answer. What happens when I have a coefficient out front? What is that coefficient doing to my radical? Nothing right now, but I'm going to do what with it? Probably multiply it, right? Because it's written there. There's no addition symbol there, so we're not adding it. We're not subtracting it, okay? Basically what this is just 5 times my root. Would you agree? Okay, so don't forget about that 5. We'll deal with it in a second. We can even go ahead and put it right here in our answer. But let's go ahead and break this down. 2 numbers that multiply to 16. You could do 8 and 2 or 4 and 4. What's 4 going to break down to? 2 and 2, both times. I'm looking for groups of 3, right? Because my index is 3. So I've got one group of 3, of 2s. So I'm going to put times 2. And then what's left? What'd you say? Yep, a 2 underneath the radical. So times a 2 underneath the radical. And now how would I simplify that? 5 times 2. What is 5 times 2? 10. Can I multiply that by what's underneath the radical? No. So I don't need to make that a 20, okay, because they're not like terms. You just leave it alone. Do not multiply coefficients by what's underneath of a radical, or a radicand is what we call that. Cool? All right, let's keep going. A couple more examples. These ones are a little more challenging, but we know how to do them. That -7 is being what? Multiplied, right? So I can just go ahead and write it in my answer. What should I do next? Yep, got to break down the 324, find 2 numbers that multiply to 324.
108 and 3.
108 and 3. Okay. How'd you find 108 and 3? Did you just use a calculator? No, you did that in your head. That works. Could you just use a calculator to start dividing the number? 324 divided by 2 divided by 3 divided by 4. Find out what you get. Yeah. 108, that's going to break down. What can that break down to? 12 and 9. Okay. What about 12? Yep. And the 4 breaks down to 2s. The 9 breaks down to 3s. Cool. I'm looking for groups of what? Yep. Wait, 3? 4, right? My index is 4. So I'm looking for groups of 4 of the exact same number. Do I have any? What are they? 3s. I got 1, 2, 3, 4, which this just becomes one group of 3. So just times 3. Yep, we have 2 2s left. We'll just go ahead and leave those for now. We'll come back to them. Let's just go ahead and get our variables. So we've got how many x's?
1.
Well, underneath, we've got 5. How many groups of 4 is that? 1. Okay, so that's one group out here. We do have 1 left. I'm just going to underline what I have left because that's just going to tell me to come back to it. I have 7 y's. How many groups of 4 is that going to be? Just 1. Okay, now I've got a bunch of stuff that's still outside or underneath my radical, right? So I'm going to draw the radical symbol. The numbers that are left under the radical are what? Yep, so 2 times 2. The x's that are left? How many? 1. And the y's that are left? 3. So y times y times y is just y to the 3rd. Is that my simplest form for this answer? No. So I need to multiply what's outside and simplify that. And then I can also simplify the inside on this one. So negative 7 times 3 times x times y. What was that?
Negative 21.
Negative 21xy with a little bit of a yawn. Okay. Underneath my root, what do I got? 4xy cubed. 4xy cubed. Writing those numbers next to each other indicates I am multiplying, right? And that's my answer. Okay, questions on that one? All right, go ahead and try number 4. All right, first thing you did. Break down the 32, okay. 8 and 4. Anybody do 16 and 2? Yeah, that's okay. What's 8 break down to? 4 and 2. 4 breaks down to 2 and 2, 2 and 2. Again, after you've broken down a number, you don't deal with it anymore. So they're not going to the party after they've been broke down. You can cross them off if you need to help you visualize that. Okay. M's, how many of those did I have? 8. And how many N's did I have? 1. Okay. So my groups here, I'm looking for groups of 4. So the numbers, do I have any groups of 4?
Yes.
What number? 2. Okay. Any groups of M's? 2 groups of M's, which becomes M squared. How many N's? 1. Is that a group of 4? No. Okay. So I can go ahead and draw my radical. What's left inside that? 2n, because we had this 2 left and we had this n left. Am I missing anything in this? The negative 2, where'd that come from? The front, right? Don't forget about those coefficients. Those are being multiplied as well. Yep, so this becomes, I'm going to give myself a little space. Negative 4 m squared, 4th root of 2n. Negative 4 m squared, 4th root of 2n. Raise your hand if you got that one. Good deal. Hopefully if you didn't get it, you realize what you did. Okay. Adding and subtracting radicals. We're going to be talking about this today. Okay? When adding or subtracting radicals, the radicand, what's the radicand? The number inside. So the radicand or the number inside, so if you need to write inside over here, just so you know, but that's what that means. The radicand and the index, what's the index? The root, right? So how many roots I have? So if it's square root, the index would be 2. Okay, so when adding or subtracting radicals, the radicand and the index must be the same. So looking at that example, is my radicand the same?
Yes.
Yes, what is it? X, okay? These both just have one x as a radicand, so I'm good there. What's the index on these? 3 and 3, is that the same? Yep, so I'm good to go. What I'm going to do is I'm going to leave the index and the radicand the same. I'm just adding the coefficients. What's 5 plus 7? 12. And then leave third root of x the same. So these are pretty easy. If they don't have the same radicand, you can't add them, okay? Again, we said the index here was 3 and the radicand was x. So when adding and subtracting radicals, it is the same as when you add or subtract variables. They must be like terms. For instance, I can't add x squared plus x squared and make it x to the 4th, right? It would just be 2x squared. That was like number 1 on our test. A lot of us did that. I don't know how we got x to the 4th, but it's okay. We'll fix it. So when adding and subtracting radicals, same as adding and subtracting variables, but we just call this like radicals instead of like terms. You might still hear me call it like terms, okay? It means the same thing. All right. Add or subtract the following radicals. 2 square root of 7 plus square root of 7. Do they have the same radicand, same index?
Yeah.
Yes. Okay, so now I just need to add the coefficients. What does it become?
2 to 7.
So 2 square root of 7 plus square root of 7.
Plus 3 square root of 7?
Yes, 3 square root of 7. It's the same thing as if I had like 2x plus x. Wouldn't that just be 3x? Right? So think of these as variables if you need to. Okay, if there's no number written in front, it's probably a 1. Okay, the next one. Same index, same radicand. No, what's different? The 6. Okay, let me show you something. What does 6 break down to? 3 and 2. Do I have any of 2 groups of the same number? No. Okay. So that tells me right there, this one is as simple as it will go. Okay, sometimes we can break those down, but today we can't, or not on this one we can't. So 4, square roots of 2 minus 4 square roots of 6. That's as simple as that one will go. So that's just your answer. I don't know why those ones have 2's written, okay, because they're not square roots, so. All right. This next one. So 4 square roots of xy minus 7 square roots of xy. Are those like radicands and like indexes? Yep, so they are like radicals. What does this become? So 4 minus 7. What's 4 minus 7? Negative 3. And then what? Yep. So on number 4, we've got 1 plus 5 minus 4. And what is that? 2. And then what is the radical?
Square root of 3x long.
Yep. Good. Pretty straightforward? Yeah, I think so too. All right. Again, it says we can simplify first and then add or subtract. Okay? Sometimes they work, sometimes they don't. Let's try this first one. Can 18 break down to what? 9 and 2, that works. What does 9 break down to? 3 and 3. I'm looking for groups of 2. Do I have any? Yeah, what is it? 3. Okay. So I still have this 6 out front, right? So basically this is 6 times 3 square root of anything left? 2. Right? We had this 2 left. Okay, now this 8, will that break down? Yeah, to what? 4 and 2. 4 breaks down to 2 and 2. Do I have any groups of 2? 1, right? So I have plus, because again we're adding these two. 4 was my coefficient times my group of 2. What's left? Radical 2. Square root of 2. Can that be simplified? Yes. So be careful. Basically what this is simplify this term, and then see if we can add them together. Okay? So looking at the first one, 6 times 3, 18 square roots of 2, plus 4 times 2, 8 square roots of 2. Can I add those together? Yeah. 26. We're not multiplying. We just keep that the same. So keep that the square root of 2. Yep, don't change that to square root of 4. You cannot add what's underneath. Okay? You're just multiplying, or sorry, not multiplying, you're just adding coefficients. Okay? Questions on that? Okay. The radical must be in simplified form before you can decide if you can add or subtract them. Okay, so like on that problem on the first page, how I looked at that 6 and I realized that was in simplest form. Okay, but I still tried to break it down. Okay, so make sure you at least try to break things down before you decide if they're simplified. Okay, so question 2. Let's try this one. 50. 25 and 2. 25 breaks down to 5 and 5. I'm looking for groups of 2. Do I have any?
Yes.
What is it? 5 and then square root of 2. What operation am I doing? Subtraction. So I'm going to put a minus sign here. Okay, so the next one, 8 and 4, that works. 8 breaks down to, and 4 breaks down to. Okay, so that happens twice here. Looking for groups of 2. So I've got 1 group of 2, 2 groups of 2, and 1, 2 remaining, correct? Yeah. So basically what this is, I'm going to take my coefficient, 5, times my first group of 2, times my second group of 2, times my 2 left over.
Can you just simplify it and make it 4 times 4 instead of putting the 2's down?
Can you make that a 4? You can, but it's easy to get, or it's easy to sometimes mess those up if you don't get in the habit of breaking it all the way down, so that's why we do that. Okay, but if you do see that that's a 4, then you're welcome to. Okay, so now we have this equaling 5 square roots of 2 minus what?
20.
Yep, 5 times 2 times 2 is 20 square roots of 2. Can that be simplified? Yeah, like indexes, like radicands, right?
Yeah.
So my coefficients, 5 minus 20. What kind of 15? Negative 15 square root of 2.
And if you're multiplying, that'd be square root of 4.
We're not there yet. We're not there yet. Yep, we're just adding and subtracting right now. We'll get to multiplication here in a second. Any questions on that one? Okay. Number 3. Go ahead and try number 3. All right, how'd you break down this first one? So 8 and 4. 8 breaks down to 4 and 2. 2 and 2. So this variable becomes 3 times 2 times, oh, we didn't break down that 4, times 2. And what's left? Radical 2, square root of 2. Yep, we are adding, so we're going to do a plus sign here. Now this term, 18. 9 and 2. 3 and 3. How many groups of 2? Just 1, and it is a 3. So we have our coefficient times 3 times square root of 2. Good. Simplify it. Yep, 3 times 2 times 2 is 12 square root of 2 plus 15 square root of 2. And what is that? 27 square root of 2. Good deal. Everybody good on how we did that one? Yeah? Okay, let's drop down to number 4. So we've got 1/2 being multiplied by this radical that we're going to break down. 48 can break down to 6 times 8.
Yeah.
Okay. 6 breaks down to, and 4, oh sorry, 8. 4 and 2. 4 breaks down to 2 and 2. Well, hold up. What are my group sizes I'm looking for on this one? 4. So do I have 4 of the same number? 1 group of 2, right? Okay. And what's left? Yep, radical of 3 with an index of 4. Okay, don't write square root of 3. Make sure you keep your same index. We then have subtraction. Yep, we've got a coefficient of 2/3 out front, so I'm just going to go ahead and write that. I like to get in the habit of writing the coefficients first just so I don't forget about them. Okay, because that's pretty easy to do on these. 243, that breaks down to what? Might have to use a calculator on this one. 3 and 81, that works. 3 won't break down, but 81 will. What will that become? 9 and 9, and 9 goes into, or has 3 and 3 going into it, right? So we're looking for groups of 4, and we've got 1 group of 3, and a leftover 3. Okay, before we subtract, we've got to multiply first. Okay, so we've got to simplify those coefficients. 1/2 times 2, 1. Do I need to write 1/4 root of 3? Or can I just write 4th root of 3? Okay, if you wrote the 1 out here, I'm not going to count it wrong. But just know that you don't have to write the 1. Okay, 2/3 times 3. So you could type that in your calculator, 2ABC 3 times 3, and that gives you what? 2. 4th root of 3. So we've got 1/4 root of 3 minus 2 4th root of 3. How would I simplify that? Yep, a negative 1 or just a negative 4th root of 3. Does everybody see that? 1 minus 2 is a negative 1, so it looks like this. Okay, but we know we don't have to write the 1. Just write the negative. That's our answer. Okay. Questions on that one? All right, we'll keep going. Do I have the same index on this one? Same radicand. No, not yet. Okay, let's see if we can get this one to simplify. So 50, so first I have just that 9 being multiplied. I'm going to start writing my answer at the bottom. 50 is going to break down to, what'd you say, 25 and 2? Okay. 25 breaks down to 5 and 5. My m squared becomes m times m, right? I've got 2 of them. So now I'm looking for groups of 2. Do I have any? A group of 5, a group of m, and what's left? A radical of 2. My operation for this one? Subtraction, so put the minus sign. Yep, got a 6 out front. Now we'll break down the 48. 6 and 8. 6 breaks down to 3 and 2, careful. 8 breaks down to 2 and 4. And I've got 2 m's. So now let's start circling our groups of 2. And what are they? 2 groups of 2, so 2 times 2. Yep, we're going to have a radical of 3, but there's one more thing. Do I have another group? A group of m? Okay. Square root of 3. Okay, let's go ahead and simplify. 9 times 5 times m. 45m. Square roots of 2. Minus 6 times 2 times 2 times m. 24m. Square root of 3. Can I subtract those two? No, why not? They don't have the same radicand? No, they don't. So this is my answer. That is my answer. That's as simple as I can get that one. So sometimes you're going to have that, okay? Don't combine the 45m minus 24m. Don't do that, okay? If they don't have the same like radical, you cannot add or subtract them. Okay, now to the fun part. The multiplying radicals. These work a whole lot different than adding and subtracting, okay? When multiplying radicals, I say a whole lot different. There's some similarities here. When multiplying radicals, you must multiply the coefficients on the outside and the radicand on the inside. Okay, you're not multiplying the coefficients to the radicands, okay? They're still not going to be like terms. You can't just combine everything into one, okay? And we'll do some examples here. So, looking at this next one, this first one, it says, given the following radicals, multiply and make sure that the solution is in simplest form. Okay, so how we're going to do this is, first off, let's look here. We've got 1 cubed root of negative 5 times 1 cubed root of 25, correct? Okay, so multiplying my coefficients first, what is 1 times 1? That's just 1, okay? So I could write it, I don't have to. But now I'm going to multiply the insides. So negative 5 times 25. Negative 125. So this becomes the cubed root of negative 125. Okay. That is not in simplest form, because it can be divided. So don't give me that as the answer. I'm going to count it wrong. Okay? I can go ahead and look at that negative. Is that going to be an imaginary number or not?
You make it,
If I make it?
you make that negative thing.
Yeah, so I'm going to take the negative out, but am I going to make it into an imaginary number or leave it as a -1? -1, because that the power of that index, is it odd or even? Odd, right? So we said a negative is okay underneath of the radical if that power is odd. If it's even, we have to make it into imaginary, right? Okay, so since it's odd, we're good on that one. We don't have to worry about the imaginary thing. So I'm just going to go ahead and know that my answer is going to be negative, so I'm going to put it up there. Now I'm just going to break down the 125. What are two numbers that multiply to 125? Yeah, 5 and 25. 25 breaks down to 5 and 5, groups of 3, and do I have any?
Yeah.
What is it? Just 5. I don't have anything left over. So my answer is just -5. Okay, questions on that? Next one. 2 square roots of 3 times 3 square roots of 12. So we're going to multiply the coefficients first. 2 times 3. Yep, 6. Okay. Draw my square root symbol here. 3 times 12. 36. Can 36 break down further? To what? 6 and 6, which breaks down to 2 and 3, 2 and 3. You might know the square root of 36 in your head, but if you don't, make sure you use the tree. Looking for groups of 2. Yep, I've got a 2 and I've got a 3. So this just becomes 6 times 2 times 3. What is that? 36. That's my answer. One thing we haven't talked about yet. It says notice, the index must be the same to multiply. The index must be the same. You cannot multiply square root of 2 times cubed root of 2, okay? I mean, you could, you'd get a decimal if you type that in your calculator, but as far as simplifying like this, you cannot multiply them together. Okay, let's go ahead. Okay, when multiplying variables with powers, we know this one. When multiplying variables with powers, you do what to the powers? Add them. Okay, same rules apply here. X squared times x squared is x to the 4th. X squared plus x squared, though, would still be 2x squared. So make sure you know the difference between that. Let's actually write that over in the side notes. X squared plus x squared equals 2x squared. But x squared times x squared equals x to the 4th. Okay? So we will start with this first one. Same index.
Yes.
Yep, so I'm good to multiply, right? Do I have any coefficients? No, just 1 times 1, don't need to write that. I'll keep my same index here. 54 times 5. 270? Okay. X squared times x cubed. X to the 5. Add 'em. Y to the 7. 3 plus 4 is 7. Is this as simple as I can go? No. Let's simplify it. 270 breaks down to 27 and 10, good. 27 will break down to 9 and 3. 9 breaks down to 3 and 3. With 10, I get 5 and 2. I then have, before I start counting my groups, I've got 5 X's. I've got how many Y's? 7. You don't have to write these out every time. You just know that 7 divided by 3 is 2, the remainder of 1. Okay, but if you want to write it out, it works. Looking for groups of 3. Looks like I've got a group of the number 3. I've got 1 group of X's. I've got 2 groups of Y. Everything else is staying home from the party, so it's going to stay inside my variable here. 5 times 2 times x squared, I've got 2 x's left, times y. Okay, that was everything I had left over. 5 times 2, x, and y. Don't make that a 52, okay? It's still being multiplied 5 times 2. Okay, now we're going to simplify the outside. 3 times x times y squared. 3xy squared. And then the inside, 5 times 2 times x squared times y. 10 x squared y. That is my final answer.
So do we get rid of 3?
Say what? Oh, what did I do there? Yeah, I did get rid of that 3. Whoops. Make sure you have an index of 3. Good call. Thank you. Cool. Questions on that? All right. Number 2. We will do this one together. And we'll try to do some on our own. Okay. 3 square roots of 7x cubed times 2 square roots of 21x cubed y squared. Are these like indexes? Yep, so can I multiply them? Sure can. We'll start with the coefficients. 3 times 2, 6. Square root, 7 times 21, 147. X cubed times x cubed, x, 6. Yep, 3 plus 3 is 6. Y squared. Just got y squared there. Cool. Is this simplified? Absolutely not. We'll break it down. Got a 6 out front. I'm going to break down the 147. What can that multiply to? 21 and 7. 21 can break down to?
7 and 3.
Yep. 3 and 7, 7 and 3. I'm looking for groups of 2 because my index is 2. Do I have any here?
Yeah,
7. I have 6 x's here. I could write them all out, or I could just know that 6 divided by 2 is 3. So I have 3 groups of x. 2 divided by 2, 1. So I have 1 group of y. Is there anything left under that radical? The 3. Yep, I didn't use the 3 yet. Six times 7 times x cubed times y. 42 x cubed y, square root of 3. Okay, questions on that? No? All right. Go ahead and try 3 and 4. Do the parentheses change anything? No, they don't. We still need to multiply. Okay? Let's go ahead and give those a shot. You can work with the people around you. The first one, example 3. First thing you did, Jordan.
You write, or you multiply them out, so 10 times 4 is 40.
Yep, 10 times 4 is 40.
And then you do like, you square root it or whatever.
Yep, my square root.
And then you have on the inside, you multiply again, 6 times 3, which is 18, and then you do
P to the 4th. Good. 3 plus 1 is 4. Everybody got that far? Hopefully. Yeah? Looking good? Okay. Now it is time to break it down, right? Okay, so our answer, we know we're going to have 40 times. Now we're going to break this down. 18.
9 and 2.
9 and 2, that works. Could have done 6 and 3 as well. A lot of these are going to have multiple ways to do this. Okay, any groups of 2 there? One group of 3. Okay, so I used those. Now let's look at that P to the 4th. Yep, that's going to make 2 groups of P. And then what's left? 2 in the radical, so square root of 2. Great job. Is that my simplest answer? Can I leave it like that? No. What do I need to do?
Multiply.
Yep, multiply 40 times 3. 120. P squared. Square root of 2. Good on that one. I think a lot of us got that, so good deal. Next one, it's going to work very similar. Do they have the same index? Yep, so I'm good to go. Multiply my coefficients. 6, 2 times 3 is 6. Keep my same index. 20 times 28. 560. Y squared times y cubed. Good. Questions on how we got there? Everybody got there? Cool. Let's break this down. So we're going to end up with 6 times, what's 560? What will go into that? Well, I heard a couple different things. 56 and 10, that works. 56 will break down to 7 and 8. 8 breaks down to 4 and 2. This breaks down again. 2 and 2. 10 breaks down to 5 and 2. How many groups of 4 do I have? 1, and what is it? 2. Okay, I'm going to write this over here so I have more room. 6 times 2. Okay, so I'm done with all of those. How many y's do I have? 5. So in a group of 4, how many of them? Just one group. And then what's going to be left underneath my 4th root symbol? 7 times 5 times y to the 5th. Or no, not y to the 5th, just y. Yep. Okay, simplify just the outside. Again, don't multiply outside to inside. It doesn't work like that. 6 times 2 times y. 12y. 4th root of 35y. Cool beans. Questions on that? Good deal. Okay. We're good on time. Be real quick. Got to go over how to combine both of them. Okay. Okay, so this next part is going to be about foiling. Okay, so make sure you pay attention to this. This is important. We foil radicals just like we foil our variables. Okay, and we're going to multiply the same way as what we've been doing. So the first thing I'll do on this is 3 times 2 is 6. Then we multiply the 3 times 4 square root of 5. So 3 times 4, those are going to be coefficients, because again, they're not underneath the radical. That would just be 12 square root of 5. Okay, next up, I'm foiling the 2 square root of 5 times 2. So multiply the 2 times 2 gives me 4 square roots of 5. And then the 2 square root of 5 times 4 square root of 5 is going to be, multiply the coefficients, 2 times 4 is 8. Multiply the inside, square root of 5 times square root of 5 is 25. Now I'm going to combine like terms here. So 6 doesn't have any like terms. 12 square roots of 5 and 4 square roots of 5, that can be combined. 12 plus 4 is 16 square roots of 5. And then we have plus 8 square roots of 25. Well, if I look at 25, I know 5 is a prime number, but 25 can be divided by 5 and 5. And since that's a square root, I have one group of 2, so that's just 8 times 5. So this now is 6 plus 16 square roots of 5 plus 8 times 5, which is 40. Well, I know I can add 6 plus 40 to get 46 plus 16 square roots of 5 as my answer. Okay, so make sure you only combine like terms, okay, just as we did before. So adding, you can only combine things with the like radicands, okay, in the same index. So this one, well, this is going to work just like if they were variables. We're just distributing out. So cube root of 9 times 5, well, 5 is going to be a coefficient, so 5 cube root of 9 plus cube root of 9 times cube root of 18, well, those have radicands. 9 times 18, let's see what that is. $162. Are those like radicands? No, they are not. Okay, so I cannot add those together as they are now, but I can break down 162. So if I use a calculator, break that down, it breaks down into 9 and 18. 9 breaks down to 3 and 3. 18 breaks down to 6 and 3. And 6 breaks down to 2 and 3. Looking for groups of 3. It looks like I have one group of 3. So this just becomes 5 cube root of 9 plus 3. 2 times 3 is going to be what's left over in my radicand, which I know is just 6. So those are as simple as they will go. Are those like terms or like radicals? No, they're not. So this is going to be my answer. I'm just going to leave it like that. Next one. Okay, so if I have an exponent of something in parentheses being squared, okay, that just means I have this multiplied twice, right? Square root of 2 minus square root of 3 times square root of 2 minus square root of 3. And now I'm doing just like what I did in example 1, foiling. Square root of 2 times square root of 2. Just multiply the inside. Square root of 2 times negative square root of 3 is going to be a negative square root of 2 times 3, which is 6. Negative square root of 3 times 2 is going to be also a negative square root of 6. And then square root of 3 times negative square root of 3 is positive square root of 9. Now we just want to simplify these, so break them down. 4 becomes 2 and 2. That's one group of 2, right? So this just becomes 2. 6 can break down to 3 and 2. Do I have any groups of 2 of the same number? Nope. So leave that one alone. Same thing with the negative square root of 6, but those can be combined together because they are like terms. So negative 1 minus 1 is just a negative 2 square root of 6. And then 9 breaks down to 2 3s, so that just becomes plus 3. 2 combined like terms, 2 and 3 can be added to give me 5. minus 2 square roots of 6. Okay. And that is it. Make sure you check Canvas for your homework. That's all I got for you today. Thank you.